Okay. Number 11.
Good afternoon, class. We're going to continue our discussion on logarithms, and we'll pick up with number 11.
11. Oh, let's see. Where is it? Okay, right. It's a single logarithm. That's another way of saying condense.
That's what condense means. Taking multiple logarithms, writing it as a single logarithm.
Log base 3 of z minus log base 3 of z plus 7. Well, it's going to look like I'm just writing the problem down and writing the answer, isn't it? I'm going to write this as just one logarithm. Ooh. The first thing I do when first thing I ask myself when I'm condensing logarithms is, will there be a fraction bar after the logarithm? Yes. Why? Yes, okay. Because of this subtraction that I've circled is why we have a fraction bar. Okay? Now, let's do this first logarithm. Will it go on top or on the bottom? Top. So that's I have a z. Now, the common mistake is to put the 8 right in front of the z, but y'all know better than that. Where does the number in front of the L go? Okay. Yeah, so z to the 8. Now, this z plus 7, notice how that couldn't be separated. You can't separate at addition or subtraction, so that z plus 7 just has to stay together.
I'll put it in front.
It's on the bottom because the minus in front, and I'm going to leave, since they're in parentheses here, I'm going to leave them in parentheses there. If you don't put the parentheses around the z plus 7, since there's nothing else on the bottom, that'll be fine. But I like leaving the z plus 7 in parentheses.
And that's not an equal sign right there.
That is not an equal sign. Oh my goodness. What did I do? It looks like I wrote an equal sign there. Just a smudge.
So we come over. We type our log.
How many of them have you forgotten to put the base in?
And remember, when you're writing it, when you're typing it in, if you type it correctly, when you type that G, it's going to bold, indicating that the program knows you're typing a logarithmic expression. The subscript button down here, where you'll type the 8, get out of the denominator, and
get out of the subscript.
Fraction bar. On top we had z to the 8th. On bottom we have z plus 7. Now, since there's absolutely nothing else on the denominator, if you didn't enclose that z plus 7 in parentheses, they'd still count it right. But to be safe, when the argument has addition or subtraction with parentheses around it, you need just make it a habit to keep those parentheses around it. That way, it's never wrong. Sometimes it's wrong to drop the parentheses, but if you type those parentheses, then it's always going to be counted right.
Oh
wow!
No.
Okay.
Let me see.
Z to the 8. Oh hell.
Tim.
Oh. Y'all see it? What did I do wrong?
See.
Okay, the base is a 3, not
an 8. Goodness.
Yeah.
I wrote a 3, yeah. Oh, wow.
There. Oh. That's why you have 2 attempts at the final exam. When you're doing your homework, you can correct those little things, but you can't do that when you're taking the test.
Let's read.
It's working.
Never type capital letters or hit the space key. If you're typing it in correctly, each logarithm will automatically bold. Logarithms always begin with the lowercase l, E-L, not a capital I, E-Y. It only shows that the first time you click. After that, if you want to reread my stupid little note, it's down there. View instructor tip. Okay? But it'll only show the first time. So let's see. Do I have room to do number 12 here?
I think you do.
I do.
That paper, Tony.
I am saving that paper. Log. Hey, there's not a subscript. So what's the base?
If you see LOG and there's no subscript, you assume a 10. That's right.
Mm-hmm.
Now, if you see LN, what do you assume the base is? E, okay.
Mm-hmm. Okay, so we're going to write this as just one logarithm. Should it say expand or write as a single logarithm?
No, it
said condense. I'm sorry, I said expand. I meant condense. Yeah.
Oh, wow. You see, they say it both ways. Condense the logarithm. If you don't know what it means to condense, write it as a single logarithm. Okay.
Oh, I would like it if they did that for all of them.
Yeah.
Okay.
That's nice.
Okay, so I'm going to write my single logarithm. Will I have a fraction bar after it? Yes. And am I going to have any exponents? No.
Because there are no
numbers
the coefficients
in
front of the logarithm? Okay.
I said the number in front of the letter L.
Oh, that's better than coefficients.
Okay. Right. What goes on top and what goes on bottom?
5x plus 7 on top.
Mm-hmm. Yeah. Since there's nothing else on top, you could remove the parentheses if you want.
But why take a chance?
And since there's nothing else on the bottom, but yeah, I'm going to go ahead and leave them. Remember years and years ago in a programming class, the teacher saying, it doesn't hurt to leave the parentheses there, so if in doubt, leave them there. And I'm not in doubt.
But still.
Mm-hmm.
Okay. So I type LOG. Oh, what happened? I typed LOG and it didn't bold. Did I really type LOG? No, I typed IOG. If it using an LOG, now it bolds, okay? Then I have my fraction bar, and on top I have 5x plus 7, and on the bottom I have just x.
Now, Tim, go to similar, redo that again. Exit out and do a similar question. Now just call out the answer, and he's not going to use any parentheses on it. But just to convince you.
I'll type LOG. What do I need to type? Now, I'll tell you right now, rather than showing your work on your notebook paper for the final, you're going to have to show your work on the paper that I provide. And some problems you don't need to show work, I know that. But if there's cut point problems and then answers and absolutely no work, then
you don't get credit.
You don't get credit.
Okay. Correct answers.
Yes, correct answers won't get credit. If it's a long I know which ones require work and which ones don't. Something like this on the final, you should
none of these.
Oh, and it's all being recorded. Okay, well, good, so that people that hear it will know to expect. I'll provide the paper before you do the work, okay? Or we'll provide it. But things like this, you don't need to show work, and I know that. So,
okay.
What am I going to do next? Y'all tell me. Okay, so there, and then, what's on top? I'm going to show you, if you don't use parentheses, it'll still count it right, because there's nothing else up on top. And on the bottom,
nothing else.
Nothing else other than just that X. And so they'd count this right even without the parentheses.
But if there was anything else up there on the top or on the bottom,
you'd have to have those parentheses. And there's another problem that I want to do, okay, before we go on. I want to make up. Here's one. Okay. This is just an example. You can do the problem, Tony. I'm just going to write it down. I'll use the natural log because I'm feeling lazy. And there's a point to this. Tony, do you see what the point is?
I'm not sure I do.
Well, go ahead and write down the ln.
Okay, so we're going to write this as a single logarithm, or we're going to condense it, whatever you want to call it. I'll write ln.
The next question, do we need a fraction bar? Yes.
Oh, I see.
Okay.
Because of which minus? The first one, the second one, or the third one? The second one.
The minuses on the inside of parentheses mean nothing, okay? They're just going to stay minuses. It's the minus in front that means that you need a fraction bar. Okay.
What goes on top? Yeah, and I'll go back to my habit of leaving the parentheses. And on the bottom? Okay. Now, what about number 13?
So, but the whole point of that that example was it's the minus in front of the logarithms, not the minuses in the parentheses, that determine whether you need a fraction bar or not. Oh, number 13.
Oh, wow, that's an even longer one.
Oh, he even adds on. You should never type a capital I into Pearson Myline. You should never type capital letters, period.
And my sentence, all logarithms begin with a lowercase l. E-L, oh wow. It was one day I was really frustrated getting all the emails about people typing in the wrong thing. I realize now they use photomath or something, got the answer, and they're just looking at the answer thinking it's a capital I. I'd spent so much time trying to figure out why would they think logarithms begin with I? And then it finally dawned on me, oh wow, they don't know it's logarithms or anything. They're just taking the answer that their phone or another app gave them and trying to type it in. Okay, 1/5 ln y plus ln, is that a z? Yeah, it's a z. Okay, so we're going to write this one as a single logarithm. The logarithm. Okay, so I'll write my one logarithm. Hey, do I have a fraction bar? No, because there's a plus here.
If you can't divide, what's the only other thing you can do to arguments? You can't divide them here. So here there was a minus, so you divided the arguments. With a plus, what do you do to the arguments? Multiply. You have no idea how many people
put the plus
put a y plus z. It's y times z.
Call out what's the first thing. Am I going to write 1/5 y or y to the 1/5? Y to the 1/5. The number in front of the letter L is always the exponent. And then the next thing I'm going to write is not a plus.
Put it here. Multiplication. We don't have a little multiplication symbol, so we just write the z immediately after it, okay? Y to the 1/5 z.
Okay. If you were going to put a symbol there, it'd be multiplication. I'm not sure that, do they have the little multiplication dot there?
I don't think so.
Oh, where's the problem?
So. I'm trying. So let me see. I type my ln And then I have, here's the little tool. So if you do the more, okay, let's
see.
look. This one right here? Yeah.
Okay. Hey,
Yeah.
so you want to type, let's write y to the 1/5.
Y raised to the 1/5. And then what do I need to do?
Hey, try using that dot.
Use the little dot and
Z.
then Z. Let's see. Uh-oh. Let's see, is it the dot? Is it the dot? Have you put it in with the dot and they counted it right? No?
Okay.
You see,
I just tend to put it in like that, yeah.
okay, here's the thing that I've noticed. For the toolbar, never click more. They give you what you need. And if you're going to use more, I was thinking to myself, after 20 years of this stuff, I never used the more thing. And I think there's a reason. If you're trying to do a more, using more and type one of those symbols, they're not going to count it right. Even though y to the 1/5 dot z was correct, it wasn't counted right. So hopefully if you did that on the test, we would spot it and give you credit. But don't show a dot for multiplication.
Okay. Number 14.
Oh, instead of that y to the 1/5,
Oh, yeah.
it could have been rewritten. You could have simplified that y, not really simplified, but you could have rewritten. How could y to the 1/5 have been rewritten?
Yeah, okay.
Okay, so you're saying the fifth
Fifth
root of
root.
y. I know what you're saying. Let's do that. Look at this one.
Oh, well, okay, it changed it.
Oh, wait. Look. There. That y to the 1/5 is the same thing as the fifth root of y. And just make sure the z isn't still under that radical.
Would it be a good idea to hit a space key to separate them?
But it looks like you did.
I know, but no, you
No.
shouldn't.
Do not hit
Hit
space
space
keys.
keys.
Do not type capital letters. So let's go back to this one here.
And type it in.
Let's type it in. We have, I'm going to say less.
Yeah.
Okay. So ln, we'd have an x to the 1/6.
Which
X
we
to
could-
the 1/6 is the same thing as the sixth root of x. And then a y. Is that what I want? No, you do not want that y under the radical. So if you're going to use a radical notation, you have to tab out or do the right arrow and then type the y. Can y'all tell the y is not underneath that radical now? Can y'all tell that the y is not underneath that radical at this point? And they better count that right. Yes. Okay. Number
Okay, I'm
15.
tired of these instructor tips.
Unfortunately, we can't get rid of them on our end because
Well, as soon as someone's clicked on it, we can't really change the assignment.
I know. So,
Okay.
okay.
Number 14. Let me see if...
While Tony's writing this problem down, I have a question for you. Be thinking about this. Are you going to need a fraction bar? No. I agree.
You know, normally I try not to write cursive except for this stuff. I write the little cursive L.
So it doesn't look like an I or a 1OG or a 10G.
Okay. So y'all have already said no fraction bar because of this plus. Hey, is there going to be a plus in my final answer? No.
The only way you can have a plus or a minus in your final answer is if you start off with a plus or minus in the original problem.
That's an argument.
In the argument, you had a minus in the argument here and a minus there. You were stuck with those same minuses in your final answer. But there's no plus here. There's no plus in the second argument, so no pluses in your final answer. Call it out.
What am I going to write? X squared and z to the 7th. Okay. Now, my habit is to put a little red dot there, but I won't since it looks like
The red dot.
the red dot gets counted wrong. So log base b of x squared z to the 7th.
Log. Once again, the shortcut for subscript is a shift down arrow, okay? I don't know what they're trying to say there. I think they're trying to give some sort of a shortcut when right there on the right-hand side, but I don't know what that's saying. The shortcut is just shift down arrow, and then get out of that subscript, x squared, get out of the exponent, z to the 7. Any questions there? Okay.
Oh, let's see. 7 ln x plus 8 minus 3 ln x. So I'm going to write this as just 1 ln.
I'll make sure you just copy. Okay. And once again, for testing purposes, this is one of those problems we know. You can
All
just,
of these are just, no work required.
once you see the pattern
written
for
work.
condensing and expanding, you don't have to show work. You could type in that correct answer, and I wouldn't wonder, oh, are they cheating? Nope.
Boss, well, your boss might.
Yeah,
Because,
our boss is, she's really,
gosh, but no, most teachers aren't doing it the one-step way. Click View an Example. How many steps are they showing on this problem? Well, they shouldn't need to show any. Well, fraction bar or not?
Yes.
Because of the minus, there's a fraction bar. Now call it out, what goes on top and what goes on bottom. Perfectly said.
you see, you must, if you type it with the x plus 8 and don't put parentheses, they're going to count it wrong, and they should. Because that 7 is impacting the entire x plus 8. That's why I say, if your argument has a plus or minus, has parentheses around it, go ahead and type it with the parentheses. It's never wrong to do so. What about the bottom? Okay, well
X
said.
to the power of 3.
Okay. Any questions there?
So let's see if you can type it in, Tim.
Well, I'm surely I can. ln, and then I'm going to use the fraction hot button. I have a left, let's just see if I did this. Maybe they'd count it right. They'd count that right. All over x cubed. They better not.
No.
Yeah, okay. And they don't give you a hint saying, check your parentheses. They just say, no, that's not right. There.
Oh.
Okay.
Oh, I like this problem. Problem 16. 5 ln x plus 4 ln y minus 3 ln z. I'm going to write it as 1 ln. Will there be a fraction bar?
Yes.
Oh, Tim.
Oh, wait.
Show me.
Make sure you didn't miscopy.
Oh, 5 ln x plus 4 ln y minus 3 ln. No, I didn't miscopy.
Okay.
So I have a fraction bar y. Okay, so because of that minus, will there be a plus in your answer anywhere? No? This plus doesn't mean a plus over here. It means both of these are on the top. So get me started. What goes on the top? X to the 5th power. But don't put a plus. Instead, what do I write? Y to the 4th. Okay? The common mistake is to put a plus there. Remember, if you put a plus there, you couldn't separate the X and Y then.
The old multiplication problems, 20 years, well, more than that. Oh, wow. But back in the early days of Pierce in my lab, when so much of it was just multiplication, multiple choice, they would have had X to the 5th plus Y to the 4th all over such and such. People would choose that. They would choose it. And no.
And on the bottom, what do I write?
Okay. The only way you can have a plus or minus in the argument of your final answer is to have a plus or minus in the argument of the original problem. There's no X plus something or X minus something enclosed in parentheses there, so you can't have a plus in the original, in the final answer's argument.
Type it in.
So I type L in, and fraction hot button, X to the 5th, get out of the exponent, Y to the 4th, on bottom, Z cube.
Okay, now we're starting something different. If at this point we haven't insulted your intelligence, we're about to do it now. Okay? If we haven't insulted your intelligence this semester, I've got to see the problem.
Okay. I thought you were going to talk about where the aliens were. Okay, there.
It says use a calculator to find the common log. Remember, common log is log base 10, and you don't have to have the base written. So log 26. Do you want to show them where that logarithm key is? On this calculator. Depends on your own calculator. Oh, you're going to take over? Great.
I'll take over for a while.
I want to get a...
Well, I have my own. Oh, let's do yours. Turn yours off. Okay, I'll take over for a while.
I'm so glad I've never watched or listened to one of these videos, because I think if I did, I'd be so embarrassed.
Yeah, our voices are sort of weird when they're recorded.
Yeah,
okay.
Really annoying.
Most calculators have two separate logarithm keys, an LOG and an LN. So taking out your calculator, and it's a good idea to bring your calculator to class for the next few for the rest of the semester, because we'll be using those logarithm keys probably. So LOG is right beside my 7, and then LN is immediately underneath it, but that's where it is on your calculator. I know, but theirs it just depends. So you find it, you found it, okay. Then they're asking for the common log of 26. Realize what they're asking for. Switch to my paper.
Oh, you want to...
Okay, what's the assumed subscript of a common logarithm? Couldn't hear you. 10. So 10, here's what they're asking for. 10 to what power? 10 to what power is equal to 26? Well, 10 to the first power is 10. 10 squared is 100. 26 is between 10 and 100. So this number here has to be between 1 and 2. But it's an irrational number. So to get a decimal value for it, you'd have to use a calculator, and you'd punch in common log, LOG. Notice it opened a parenthesis. If your calculator opens a parenthesis, when you press that logarithm key, you're going to need to type in the argument 26 and then close it.
Get into the habit of closing the parentheses, even if your calculator gives you the answer if you don't, because there's going to be some stuff that...
Really messy stuff coming up in the next homework assignment. And if you're not closing the parentheses, you're going to be getting the wrong answer. My logic said it had to be that 10 to the first is 10. 10 squared is 100. 26 is between 10 and 100, so the exponent has to be between 1 and 2. So, what was that? They want it rounded to 4 decimal places, by the way.
That's what I was looking at. Round to
4 decimal places. 1.41. Oh, wait a minute. Now, it's going 49. We're rounding to 4 decimal. So, look at that 7. After 4 places. This is the usual rules for rounding, so 41497. Is that going to stay at 49 there, or is that going to be boosted up to 50? Okay, that 7 is 5 or bigger, so we want to increase that 9. Well, there's not a digit bigger than 9, but when you look at, think of that as 49, it's boosted up to 50.
The actual question is, how did they figure this out before calculators?
Slide rule.
And tables.
Tables and
Lots
slide
of
rules. Tables and slide rules. So let's punch it in.
1.450.
No, 4150.
1.4150. Now, a word of warning or explanation. Why does it say the solution doesn't exist? Well, you can't take the logarithm of a negative number. If you were trying to say this,
10 to any power, we know a positive number to any power is going to be positive. Remember, the base has to be positive. A positive number to any power must equal a positive number.
So can you get 10 to a power to be a negative number? No.
Look at what happens if you try to find the logarithm of a negative number. It's going to say non-real answer. What was that early generation graphing calculator? Was it the TI-81? They'd convert to real imaginary numbers. They converted everything. Oh, a log of a negative? They gave the imaginary value of that. But no.
It was a real early one. They then stopped that.
Because educators complain too much.
But non-real, that's the same warning you get if you try to take the square root of a negative. Y'all know the square root of -4 isn't -2. It's what? What's the square root of a negative?
When you have a negative under the square root, what does your answer pick up?
Starts with an I.
An I? It's an imaginary number.
It should be 2I, but this calculator won't work with imaginary numbers. It gives you that error, non-real answer. It'll turn out, if you pursue your mathematics and keep going and going with it, it's going to turn out that the log of a negative is one of those imaginary numbers. That's why it says non-real answer, and that's why on here it gives you the option solution doesn't exist. But if you get that answer,
I think there's a problem.
Then you've messed up punching it into your calculator.
Okay.
The answer of doesn't exist. If you find yourself getting that non-real answer, you've done something wrong.
Does anyone have one of those little Casio calculators that we were talking about? Yes, okay. And so, do you have an LOG and an LN key? Yes. Now, y'all have something else on those calculators that's really nice that we'll get to in a moment, okay? Mm-hmm. But it's direct entry. You punch in the log key first. Am I correct? So it's just like the...
Is there anyone in here that has a calculator where you have to enter the 26 and then the LOG? You enter it in reverse? I hope there isn't, because those are
This is
hard
when
to work
at the
with.
beginning of the semester I said you don't need a big fancy expensive graphing calculator. Any direct entry scientific calculator will work. By direct entry, we're finally at the point where we can understand what that means. You have to enter it directly, log, and then the argument. There are some calculators that use reverse notation where you enter in the argument, the number, and then press logarithm. And if that's the case, it's a little difficult punching the stuff in as we move into the next assignment. Okay, number 18. Okay, I need to, when you look at my calculator up here, I have two logarithm keys, an LOG and an LN. What's the base of this problem that we have? That's a log base 6, isn't it? Do I have a log base 6 key on my calculator? No, I don't have a log base 6. You might have one. That's what's nice about those Casios. It's amazing what they can do. Yes, it's one of the.
Show it. Oh, well, see, I'm doing it the old-fashioned way.
I'm going to do it the old-fashioned way
and then
first.
we'll show your calculator.
Okay.
Does yours have the little log with the little base?
Oh, wait. Switch it. Oh, damn it. I'm back to pressing. It's so bizarre. I have a touchscreen computer at home, and I just have this desire to reach over and start touching. There's something called the change of base formula.
Do y'all ever, if someone has a paper picture, do you ever start doing this? With old relatives, they'll have paper pictures showing them to us, and I'll be like this, trying to get it to blow up so I can see the picture better. And then, oh wait, no, forget it.
Most calculators only have an LOG and an LN key on them. So if you had something logarithm to the base, I'll just say a log to the base b of x. You can rewrite this log base b either as LOG or LN so that you can evaluate it using a calculator. It's going to be a fraction. You have to decide what you want to use. Do you want to use LOG or do you want to use LN? I prefer LN, okay? In a business environment, natural logarithms are more, and scientific environment, natural logarithms are more commonly used now than common logarithms. It's the natural log of the argument, x, the thing that's written higher up, divided by the natural log of the old base, or if you're going to write it in terms of common logarithms, it's the common log of the old argument divided by the common log of the old base.
The one that's written physically lower is the number that's going to go in the bottom.
The thing that's written physically higher, that's what goes on top. And you cannot mix them. It's either LN over LN or LOG over LOG. I remember our last chemistry class, the lab, Tony and I were lab partners, and we were always the last people finished with the lab. But that last lab involved logarithms and some logarithmic calculations, and it was a log to some real weird base, okay? Tony and I were the only math majors in there, and we knew the change of base formula when we saw, we got to change the base, use the change of base formula. Everyone else, they'd raced through it, and they were turning in their reports, and Kelly wouldn't leave until they had the right answer. No, you got to do it again. And she was heartless. She wouldn't tell them, you got to use the change of base formula. Here's what it is. She said,
there were no phones or anything, no computers. You couldn't ask,
And we were sort of heartless also, as we gleefully did it and turned ours in. And
but everyone laughed at us for always being so slow.
Yeah, but it's by the last one we finished before
I don't think it's a bad idea to be slow when dealing with chemicals. Am I wrong?
Oh.
You want to be careful and slow.
Let's go on. I was thinking we were going to finish early today, but okay, it's too many trips down memory lane. Okay, log base 6 of 15. We're going to do this the change of base formula, and then I'm going to borrow someone's Casio calculator and use their little log base B key, if that's okay. And so my calculator up here doesn't have a log base B key. It only has an LN and an LOG. So I draw my fraction bar. It's LN, the old argument, 15, divided by LN, the old base, 6. This is asking 6 to what power gives us 15? Well, 6 to the first is 6. 6 squared is 36, so we've skipped right over the 15. So it has to be between 1 and 2, but that's all I can come up with without using a calculator. So
Watch out.
if you notice how my calculator opened up a parenthesis, and I bet some of y'all's did also. So you've got to close the parenthesis before you say divided by. If it opens a parenthesis, you type the argument and then close it.
Let's see. Is this 4 decimal places? Yeah, round to 4 decimal places.
So 1.51139.
So
1.511. Is that 3 going to stay a 3 or is it going up to a 4? It's going to go up to a 4. We're using the traditional rules of rounding, okay? If the following digit is a 5 or higher, you boost up. If it's lower, you truncate the rest of those. Oh, wait, that's a 4. 1.5114.
1.5114.
Okay. Now, switch back to the camera. Give me the, Tony, get one of the
Oh, by the
Casio.
way, we had said you could use either one. If we had used log,
LOG 15.
as long as you don't mix them.
Either use log over log or LN over LN. And look at what you get. You still
If you
get
mixed it,
you'd get the wrong answer.
if I use log and ln, oh wait, no,
Go back.
6, close, enter. You see, wrong answer then. Who wants to let us borrow their calculator?
Okay.
Oh, this is such a nice calculator.
Okay, let's see if I can get it. Oh, goodness. Okay, so I see the LOG key and I see the LN key, but look right above that.
Oh,
do y'all see that little log subscript box and then a box? You press that, and it's like just a modern equation editor. You type in, can y'all see? Can y'all see it better if I do it like that? The subscript is what? 6. And the argument is, no, wait, I got to go back. Okay, wait, I keep wanting to tap, but I know that's not it. Do I do a right arrow? Oh, that's it. I do a right arrow.
Oh, Tim, I was reading about how the baby boomers can't do technology. You're just like it. And I'm seeing you in here. You're reflecting.
Oh,
Do y'all
wow.
see him? Oh, wow. Okay. But, oh, wow. That's a really nice.
This is for what it's worth. Do y'all remember ballpark figure how much it cost? Oh, God. This would have been just so valuable back when we were in school in the 80s. Something like this. Wow. Oh, goodness. If I got to develop that time machine so I can travel forward in time. No, so that I can go back in time with those calculators
And sell them. Make a fortune.
Okay, buy them at $10, go back in time, sell them for $200 each. I take that money, buy Windows stock, right? And then come back
Microsoft.
forward. Microsoft, yeah.
Apple.
No, Apple. well, remember they sort of went, you wouldn't want to have bought it in the 80s.
Yeah, they did sort of go.
Yeah.
Anyway,
Okay.
I wonder what happened. That stock.
Oh, let's
Okay.
see. Here's another one, okay? But those little Casio FX, what number was it? 300. Both 300? Well, I think the FX 250 has it also, but probably the 250 doesn't exist anymore.
Yeah, so this was the thing we have here is an 83, and I don't think they sell it.
They had like three of these in like different colors, the white one, this one, and
$10 or $11. That is
Wow.
incredible for what you're
So you
getting.
can beat us through. Y'all do this problem while we're doing it the old-fashioned
We're going to
way
do
with
it the
this.
old-fashioned way, and you're going to use your fancy Casio calculator. Oh, goodness. Okay, it's a log base 8. I'm going to use LN just because I prefer LN. We spoke to a former classmate that was majoring in math and ultimately didn't finish it and switched to computer science. And he's a programmer for Texas Instruments. And it was a reunion. We're talking about 20
Wow.
years ago, right? But now you're talking to somebody that, a casual acquaintance from years back, and what do you talk about? Oh, I'm like, hey, I have a question for you, Paul. Why is LN now the logarithm of choice rather than LOG? The common logarithm is not very common anymore. Why is it more desirable, the LN logarithm? And he was like, 2.7, it's a smaller base rather than 10, a larger base. So why has LN become more popular?
There's some
Why-
calculators that only have a direct LL key, not LOG key.
Right, the LN key. There are some scientific calculators that have the LN key, but not the LOG key.
Enough talking, Tim.
And here we go. When you're punching this in, I'm assuming not everyone has one of those Casio calculators, so some of y'all are having to use the change of base formula.
If everyone has one, then tell us so we can stop this and just go right on along. Make sure you close the parentheses. If yours is one like this, where you have to open where it opens parentheses, and you've got to close them.
And how do they want it rounded?
Oh, let's see.
I don't know if it's all 4 decimal
Four
places.
decimal.
4 decimal.
I think it's the next assignment where on one they'll say round to 3, that next one round
So a
to
negative
4.
2.21. Is it going to stay a 4.6 or become a 4.7? Don't say anything, Tony. It stays a 4.6. Good. Okay.
Just for people that are doing it the way we're doing it, just to make sure that you realize, notice, what did I do? I didn't close the parentheses. Is it going to give me the same answer?
Certainly not.
It's going to give a wrong answer. Negative 2.2146. Negative 2.2146. Uh-oh.
2.1. Alien, let me make sure that miscopy the problem. Okay. Alien 0.01 over ln 8. Punch it back at ln 0.01 divided by
Oh, look,
ln
y'all
8.
see it?
No, I don't.
1,4. What did I type in? Well, I'll switch the 1,4 and it should be a 1,4, not a 4,1.
Switch it back my paper so they can see that I had the. Okay.
Yeah, you had the right answer. I just typed it in
21.46.
wrong.
Okay, good. Why are you saying save?
Wait.
Why do you say
Oh.
save? X that out and check your answer.
Oh, yeah. Okay. Okay. Last problem.
Really?
Well, we're about to do. Do you want to go ahead and talk
now,
about it?
I need to talk some, okay?
What up? Oh, wait, I guess this problem has some LNs in it. Okay. I regret
Okay.
doing that on every one of those problems. It was just,
I I want to go back to, I want to remind y'all of something that we were using at the very beginning of this whole logarithm assignment. Here it is. Log base b of b to the x equals x, and b to the log base b of x or equal to x is equal to x. If the base of the logarithm equals the base of the exponent and they're performed consecutively, they cancel each other out in either direction, because from the definition we were able to see that, the variables were just being reversed between logarithms and exponentials. So I'm going to restate these in terms of the two special logarithms. I'll first of all state it in terms of ln. Instead of log base b, ln is log base e. So ln I'm restating this. Log base b is being replaced with ln. That's log base e. So this base would have to be an e. When you see that ln, you think to yourself, there's a little e there. The logarithmic exponential are performed consecutively. They cancel each other out, leaving you just an x. Let's rewrite this part of the statement. The base is an e. E, instead of log base e, we write ln x. They're still performed consecutively, so they cancel each other out.
So what you're saying is if ln and e are side by side with nothing in between them,
In either order, if they're performed consecutively,
they cancel out.
because of their inverse functions.
E and ln side by side, nothing between them.
Now let's write it for common logarithms. The common logarithm is log. You don't put the little base, but what's that base assumed to be for log? 10 to the x reduces to x. And if we reverse the 10 and the log notation, 10 to the common log of x. Those are inverse functions. They cancel each other out, leaving you with x. So whether it's common logarithm and the exponential to the base 10, or natural logarithm and the exponential to the base e, when performed consecutively, they cancel each other out. With that in mind, let's look at number 20.
This is the last problem, so is it going to be the hardest one?
Maybe. Okay, they give us the function f of x is equal to ln x. And they give us, I'm going to write all three parts down. They want us to find a.
And you can write as big as you want, because that's the last one, and you have all that room.
I'm going to.
Oh, not giving us much room as I thought.
E to the negative 3x.
With function notation, remember whatever's inside the parentheses.
Oh,
you
no,
plug
it's just
in
e
for
to the
x.
negative 3. Where'd I get an x from? It's just
I thought you were going
e to the negative 3.
Then go ahead and write. I thought you were writing all three of them.
Oh, I am, aren't I? You're right. E and e to the 4, ln 3. This problem makes some good points here. We know how function notation works. This says go to your function f, and wherever you see a variable, replace it with, in this case, e to the negative 3. So we're going to come up here, replace that x with e to the negative 3.
How would y'all draw the line to show what's canceling out?
What's going to cancel out here? Show them your rule.
Here's my rule. When I restated that earlier, the earlier properties in terms of of LN and LOG.
Which the one you would use?
Which one would I use? 1, 2, 3, or 4?
Well, not 3 or 4, isn't it?
It's 1. L and E are consecutive. They cancel out, leaving you with that exponent. The L and E cancels out, leaving us with just the exponent -3 for our answer.
Okay.
Now, the
Do all
next
3 of them, and then
yeah.
I'll type in the answer.
The next one, go to that same function, replace the variable with an e to the ln3. So we have ln, and we're going to replace that x with an e to the ln3. Some people go into cancellation frenzies when they see e's and ln's together.
The answer is not 3.
3. The answer is not 3. There is a 1-to-1 correspondence. You can cancel out an ln and an e performed consecutively, or you can cancel out an e to the ln performed consecutively. Either way, there's something else you're going to be left with other than just 3. What is it? You're going to have one of the ln's. They don't all just disappear. It's either you can cancel the ln e, and then you're left with an ln3, or you can cancel the e to the ln. Either way, you're going to be left with an ln3 for your answer.
Look at these marks. Look at the things. You can either cancel like this, in which case the answer would be the green ln3.
That looks black to me, but it
or
is green.
You can cancel the green e and the green ln, and you'd be left with the blue ln and the green 3. Color doesn't matter. The answer is ln3, regardless of how you cancel. But do not cancel all of that and just get a 3.
Last one, we go to our function f, wherever we see a variable, replace it with e to the 4 ln3. So we have an ln, replace that x with an e to the 4 ln3. And in this case, I think there's only one place that we can cancel.
The one above it, you had 2 ways you could cancel, like this or like this.
Well, we can cancel that ln e right there. Can we cancel the e and that ln that's following? They're not consecutive. There's something between them. What is it? That 4. So you can't cancel like that. All you can do is say, okay, I have one pair I can cancel, and that's going to leave me a 4 ln3. If you view an example, they may then decide they may take the 4. What can you do to a coefficient if you want to get rid of that coefficient? You can't multiply the 4 times 3 and get 12. What can you do to the coefficient? How do you get rid of the number?
L is a... When
The
we're
4?
expanding and condensing,
We
it's
could
the
bring it
exponent.
up. I wouldn't recommend doing that. Well, in this case, 3 to the 4th, I can do that in my head, 81, but they'd accept this. I like the smaller argument. I'd leave it like that, 4 ln3. But they'd accept ln 81. I don't think they'd accept it if you put it here, just 3 to the 4th, but I think they'd accept either one of those. So if you're going to bring the 4 up, you got to go ahead and expand it. My advice,
leave it as 4 ln3.
leave it as 4 ln3. Okay, go ahead and type in the answers.
Oh, wait. Okay, so the first one was just a -3.
And then a ln3. Click in the box.
ln3.
And finally a 4 ln3. Yours doesn't bold, you're typing an I-N, okay? Do not type I-N. Oh, wow. We got every one of them done. Oh, gosh, this is one of those times I regret, or I hate to say it, but I'm going to ask, any questions? We've been doing this so much the past 2 class meetings. Just jump in. If you haven't worked on it, work on it, because we're going to be using our calculators, and we're going to answer a question that was asked last week? No. How to solve exponential functions when there's not a common base?
I'm thinking it was a week ago today.
Yeah, that'll be what we do. Start with on Wednesday. Let me see.
Go ahead and stop the recording.
Any questions before I stop the recording?